Okay, I gotta start this again. So translation is a movement, right? Where you're moving your points or the point. Same units, the same amount, same distance to either left or right on the x-axis or up and down on the y. So for this particular problem, let's start with the rule. So our initial coordinates x, y, how are they going to change? Well, on the x-axis, we're going to move left. So that means on the x-axis, it's minus 6. And then on the y-axis, are we going up and down? We're going down. And how is that represented? We can represent that by, say, subtract 5. So let's take the point. You know what? I'm actually going to do it this way. Point A, 6, 5. So let me show you what happens to point A. Well, the x value is 6. We're going to subtract 6, so we get 6 minus 6, so we're going to end up at 0. The y value, we're at positive 5, and if you're positive 5 and you go down 5, you end up at 0, 0. So let me plot point A. And then, sorry, so that becomes A prime. B is 2 and 7. So 2 and 7 becomes, how does it become B prime? So from the 2, if you're on 2 on the x-axis and you go left 6, right, what ends up happening? You end up at negative 4. On the y-axis, if you're at 7 and you go 5 down, you end up at 2. And then C, which is 1, 3. How does it get to C prime? Well, if you're on 1 and you go left 6 units, you end up at negative 5. And if you're at 3 and you go down 5 units, you end up at negative 2. So now let's just plot. A, 6 and 5, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So 2, 4. Actually, I need my glasses. Oh, here we go. Oh, no, getting old. I can't even see this anymore. Well, I can see, but it's just 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5. Okay. Remind me to get coordinate plane with numbers next time. So that's A, and we're going 6 left. 1, 2, 3, 4, 5, 6, and 5 down. 1, 2, 3, 4, 5. So here's A prime. B, it's a 2, 7. 1, 2, 3, 4, 5, 6, 7. So this is point B. Again, this is going to also move 6 left. 1, 2, 3, 4, 5, 6, and then 5 down. 1, 2, 3, 4, 5. Oh, we'll connect the dots a little bit later. C is 1 and 3, so 1 and then 3, so here's C. And then C prime is going to be 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, and here's C prime. You may connect the dots if you like. So notice it's going to be a congruent triangle. All right, same exact everything. Same orientation, same same area, same side length, same angle, same everything, except that it's shifted to the left 6 units and 5 units down. That's it. That's translations. There are nothing more exciting about translations. So let's do another one. Here you're given the rule. It's telling you what's happening, right? On the x-axis, I want you to go 4 right. So let me write a description. So we're going to go 4 right. And then on the y-axis, down 3. Let's keep it simple. So let's plot this one. 1, 2, 3, 4, 5, 6, 7, negative 7, and 4. 1, 2, 3, 4. So here's R prime. So we want to go 4 right. 1, 2, 3, 4, and then 3 down. 1, 2, 3. So R prime is here. S is negative 3 and 3. So negative 3 and negative 3. So here's S. So S prime is going to be 4 right and 3 down. 1, 2, 3, 4. 1, 2, 3. So here's S prime. I'll connect the dots. And then T is 1 and 4. 1 to the right and 1, 2, 3, 4. So here's point T. I'm going to move point T 4 to the right. 1, 2, 3, 4, and 3 down. 1, 2, 3, and 3 down. So this is T prime. So let me use blue to connect the original points. And I'm going to use red for the image. And again, notice that it's a congruent right shape. Angle R is the same as angle R prime. Side RT is congruent to side R prime, T prime, and so forth and so forth. So that's translations. There's not much else I can show you here. A couple of problems at the bottom. On the problems we don't have the benefit of the coordinate of the grid of the coordinate plane, so we have to figure it out without it. You can draw it just for you to think about it. So let's now write it here. So -2. So think about -2 and -5. Right, here's my x value, this is my y value, and the new, so this is f, and it became f prime, and it moved to 5, -1, and again, this is my x value and my y value. So let's see what happened to the x. So you were at -2, and now you are at 5 on the x-axis. So if you're at -2 and you ended up at 5, you move to the right, first of all. And how many units did you move to the right? You moved to the right 7 units. That's what happens with dx. So from -2 to 5, this is what happened. A shift, a slide 7 to the right. Okay? And then on the y-axis, you were on, think about it, you're on the -5th floor, right? And then you went up all the way to the -1st floor. So you went up, right? You went up, and how many floors did you go up? So your slide, you went up 4 floors. So remember, you're at -5. So here is +7 because you went to the right 7, and this one from -5 to get to -1, that means on the y-axis you went up 4. So that's our rule. This is what happened. So this is what happened for this point for f to become f prime. So they're asking us, hey, take point K, right, and do the same thing. So K is 4, -4, and 2. And let's apply the same rule. So I want you to take it. So if you're at -4 and you go 7 to the right, you're going to end up at +3. If you're on the second floor, right, on the y-axis, you're on +2, and you go 4 up, you're going to end up at 6. So using the same thing that happened to point F to point K, this is the answer. I think the second one's the same thing. So it's telling you that you are at point 9, -2, and they want you to apply this particular rule. So let's do that. So you're 9 and -2, and you're going to go to L prime. So and again, let me write that this represents the x and this is the y. On the x-axis, you are at 9, and they're saying, hey, -7. So where are you going to end up if you're at 9 and you go 7 to the left? Well, you're going to end up at 2. The y, you're at -2, and it's telling you, hey, go up 4. Where are you going to end up? So -2 plus 4 is 2. So L prime is 2, 2. Notes, you can write whatever notes you want to help you with translations. Okay, anything important that is important to you. Okay, so we're going to do rotations. You notice that the first problem is a rotation clockwise, 90 degrees. The second one is a counter, and then we'll do 180. Okay, again, just this is a review. So the things that matter. So the first of all, you can write that this is quadrant 1, quadrant 2, and remember it's always in this order in quadrant 4. Plus plus. This is minus plus. This is minus negative negative, and this is positive negative. Those are the characteristics of your quadrants. Point A, and let's do it. So we're rotating clockwise, so I don't know. Clockwise means we're going this direction. Point A is -2 and -5, which is right here. Okay, it is in quadrant, and now let me write that it's in quadrant 3. Right? I'll do one point at a time, and I'll write point A. So A is in quadrant 3, and if you rotate 90 degrees clockwise, it means that point A is going to go from quadrant 3 to quadrant 2. That's it. It's one quadrant over. -2, -5. Also, it's going to go from quadrant 3. It's going to land in quadrant 2. So let me just write that ahead of time. And what happens to the two numbers, -2 and -5? They switch, right? They switch once. I'm going to write them without the sign. So it becomes 5 and 2. And in quadrant 2, x is negative, and then y is positive, and that's my answer. So a is going to go from here to negative 5, comma 2, and this is a prime. B is a negative 6 and negative 1, which is right over here. Let me write b prime. Sorry, not b prime, just b. So let me, and b is also in quadrant 3. And b simply is going to travel from quadrant 3 to quadrant 2, so we can write that. So these two numbers are going to switch places. It's going to be 1 and 6, and then we apply the characteristics of quadrant 2 to 1 and 6, and in quadrant 2, x is negative and y is positive. And then, so let me look for that, negative 1 and positive 6 right here. So that's b prime. C is negative 3 and 4, so negative 3 and 4, so here's C. And C is in quadrant 2, be careful, okay? C is in quadrant 2, and if C is in quadrant 2, where is it going to end up? End up in quadrant 1, so we can already write that C is going to end up in quadrant 1. Negative 3 and 4 switch positions, and in quadrant 1, everybody's positive, so that's end up being the final number. So 4 and 3 is right here, and this is C prime. Let me connect the dots. So the first shape looked like this. And then I change colors. And the second shape, after rotation, looks like that. Okay, so what's the rule? Well, look at your numbers. So we're going to write that my original numbers, x, y. First of all, 9-degree rotation clockwise. What happened to them? They switched. All right, so negative 2 switched, right? Negative 2 went there, but notice that when negative 2 got to its new position, it wasn't negative 2 anymore. It was positive 2. So that minus sign there just means, hey, negate. Whatever it was, change it. So x was negative 2 to begin with, and then if we negate that, do the opposite, it becomes positive 2. And then negative 5, which was the y, came to the front, right? And it stays as it is. All right, so they switch positions, and x switches signs. That's it. That's the rule for rotation of 9 degrees clockwise. Now let's do counter. Let's set up everything again. Quadrant 1, quadrant 2, 3, 4. Positive, negative, 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 positive, positive, positive. All right, so let's do quadrant, sorry, 0.24. So 2 4s right here. You know what, this time I'm going to do all points. That's point A is in quadrant 1. Okay. Point S is 2, negative 2 is in quadrant 4. 6 and 3 is in quadrant 1. 6 and 3, that's T. What? Oh, not ABC. It's R, S, T, and then U, 7, negative 5, which is right here, and that's in quadrant 4. It helps knowing what quadrant they are in. Okay? So there's a quadrilateral. So it's a 9 degrees counter, so we're going this direction. So everybody's going to shift one quadrant counterclockwise. So R and T will land in quadrant 2. And S and U will land in quadrant 1. So R and T, right, R and T will land in quadrant 1. Sorry, quadrant 2. And then S and U will land in quadrant 1. We know that. All right, so let's make the change. So 2, 4 will become 4, 2. Yeah, we switch the numbers once. And in quadrant 2, X is negative. Done. 2 and negative 2. It's going to be 2 and 2. In quadrant 1, everybody's positive, so I'm done with that. 6 and 3, switch positions. Becomes 3 and 6. And in quadrant 2, negative 3, X is negative. And then T, 7 and negative 5, becomes 5 and 7. And they both land in quadrant 1, where everybody's positive. Done. Let me plot them first. So negative 4 and 2, negative 4, positive 2. And here is point R. Point S is 2 and 2. Right here. S prime, R prime, apologies. Point T is -3 and 6, which is right here. And let's call it T prime. And point U is 5 and 7. 5 and 7. U prime. So there you go. Right, you can tell that's a 90-degree rotation. S and U, who were in quadrant 4, now in quadrant 1. R and T, you can notice that they were in quadrant 1 and they're now in quadrant 2. So we're good. So what's the rule for this rotation? So notice, if you look at the numbers, compare this one to this one. So they do switch positions, right? Y and X. And we're going to negate the Y. Right, so if you look at point R, it's 2 and 4, which changes to -4 and 2. So the numbers switch position, and we negate the Y, right? We're going to negate the Y. The 4, notice that this was +4, now it's -4. X, which is 2, stayed as 2. Okay? Here's the next one. 180. That one is, I think it's simpler than the other two. So let's do the points. X, 0 and 5, so 0 and 5. So here's X. It's not on the quadrant, it's on the Y-axis, right? We're going to go 180. So Y is -4 and 2. -4 and 2 is right here. Y is, we're quadrant 2. So quadrant 1, quadrant 2, quadrant 3, quadrant 4. And then X, -7, comma 1. It's right here. And that's in quadrant 2 as well. So 180-degree rotation. Be careful here. Everybody shifts over, and sorry, it doesn't matter if you go counterclockwise. So X and Y, who are in quadrant 2, will be in quadrant 4. So we can write that X and Y will travel to quadrant 4. And the X over here, right, is on the Y-axis. But he's going to go from here, imagine here, going here, all the way down here. Okay? So if you switch the numbers, 0, 5 becomes 5 and 0, and you switch again, it becomes 0, 5. So all the numbers are going to be exactly the same. 4 and 2, 7 and 1, because you switched twice. So they come back to the original. Now we just got to apply the characters. So 0, 5, okay, it's going to be 0, -5. X is going to come all the way down here. So that's X prime. X prime, Y prime. Sorry, why do I have two X's? Sorry, one of these, I don't know, X, Y, so let's call this Z. Okay, this is Z prime. 7 and -7 1. So instead of X, we call that Z. I don't know why there's two X's. Okay. So that's that. 4 and 2. In they land in quadrant 4. In quadrant 4, the second number is negative. Right, the Y coordinate is negative. So 4, -2 is right here. And then 7, -1 right here. And this is Y. And this is Z prime. If you connect them, we connect the first one. So that's the triangle. Okay, and then in blue I'm going to do the other triangle. Notice that they're exactly the same triangle, right? Except 100 degrees rotated. What's the rule? Well, this one is easy. XY is going to still be XY, but their signs are going to be opposite. Whatever they were before, they're now the opposite. And that's the rule for a 180-degree rotation. Okay, so now without the coordinate, let's see if you can apply this. So, so it's a 90-degree clockwise. So again, if you can draw just a little one over here, you can say that -7 and 4, first of all, is over here. It's in quadrant 2. And clockwise, we're going this way. So this point is going to land in quadrant 1. Okay, that's what you got to know. It's got to travel from here to quadrant 1. So you can draw something like that on your quiz. So the rule is XY, right? So it's -7, 4. So first of all, let's do that. So M is -7, 4. So M prime what happens, those two numbers, they switch once. Now become 4 and 7. And in quadrant 1, everybody is positive. Okay? So the rule was xy. They switch one, yx, and we negate the x. So notice that the originally 4, okay? 4 stayed the same, so the y stayed the same, but the x, it went from -7 to 7, so that changed signs. Okay? Rotate C 5, 9. So again, if you want to, right? Just for you to remember, where's 5, 9? 5, 9 is in quadrant 1, so I'm going to write it. And after a 180-degree rotation, it's going to land in quadrant 3. It's going to be over here. It's going to go 2 quadrants over. So the rule is xy. It's still xy because you switch 5 and 9 becomes 9 and 5, and then you switch again 5 and 9, so it's still 5 and 9. But guess what? You negate everybody. So the rule. Sorry, that's not what I meant to do. So, well, that's the answer. But so it's still x and y, but you negate whatever they were. So 5, 9, C. It's going to become C prime. Still 5 and 9, but in quadrant 3, everybody is negative. So that would have been the answer. 9 and -4. Okay, so again. Where's 9, -4? 9, -4 is here in quadrant 4. Okay, and they're saying that this is point A, and it traveled this way to -4, -9. It went to quadrant 3. So this is where A prime is. So it went from here to here. So describe the rotation. It was a rotation of 90 degrees. Was that counter or clockwise? Well, it was 90 degrees clockwise, sorry. Right, because we're going with the clock. 90 degrees clockwise. So if you remember the rule that we just did, 9-degree clockwise, what happens with these two numbers? They switch positions. Switch positions, and we negate the x. So if you think about it, 9 is now -9, and -4 stays the same. Okay. J. So again, let's do a little coordinate. J is here. 5 and 2 is 5 and 2. Both are positive, so that means they're in quadrant 1. So they're somewhere here. Let me call that J. And then the new location is -2 and 5. -2 and 5. The first one is negative. The second one is positive. It means that it went from quadrant 1 to quadrant 2. So J traveled this way. So we know that it was a rotation, and it traveled 1 quadrant over, so it's 9 degrees counterclockwise this time. Counterclockwise. So what was the rule? Well, xy. So look at xy, 5 and 2, right? And it became yx. But notice that the x is the same number, so it becomes -2 and 5. Notice that this x and this x is the same, so that didn't change. But the y, which was 2, is now -2. Right? So whatever the y is, we negate it and became negative. So the rule is this. So anytime you have a rotation of 90 degrees counterclockwise, change the two numbers, right? And then negate the y. Whatever the y is, make sure it is the opposite. If it's positive, it's now negative. If it's negative, it's now positive. That's rotation. Again, notes for yourself. Use this as your review sheet. Reflection. I urge you to highlight your line of reflection. So the first one says reflect over the y-axis. Where's the y-axis? This is the y-axis. So this one, we're going to reflect it over here. That's our mirror, our line of reflection. Well, these ones, right, the easy ones. So xy, think about this for a second. Let me plot 6, 5. 6 and 5 is right here, point A. If you're going to reflect this over the y-axis, it means that our image, A's image, is going to be on over the y-axis, and it's going to be right here. That's where A prime. Notice that It's 1, 2, 3, 4, 5, 6 units away from the line of reflection. And on the other side of that, 1, 2, 3, 4, 5, 6 is the same distance. So both A and A prime are equally distant to the line reflection. What happened to it? If you want to think about the rules, notice that this did not move on the y-axis. There was no shift up and down the y-axis, but there was a shift left and right. So x and y, it's still going to be x and y. The y hasn't changed. It didn't go up and down. A didn't go up and down, but x changed, and we're going to negate x. Let's see if that works. So A was 6, 5, so let me just write A. So A prime ends up being negative 6, comma 5. See how that rule applied? Point B prime, it's now going to be negative 2 and 7. We negate the first one and keep this y coordinate as it is. And then C prime is going to be negative 1, comma 3. Well, let's see if I'm right. Point B is 2 and 7, so 2 and 7 is right here. Its image on the other side should be exactly the same distance away from the line of reflection. So this is point B prime. Point C is 1 and 3. And C prime would be, so this is C and C prime. Notice, again, this is a reflection over the y-axis, where the x coordinate changes, but the y coordinate stays the same. Okay? And remember that the only thing that changed here was the orientation. Sorry, and the location too. So that's a reflection of the over the y-axis, and this is your rule. Reflection over the x-axis. This one is, so highlight, always highlight your line of reflection. Okay, so we're reflecting over this line. So think about that as the lake, and we're drawing a mountain. So negative 7 and 4 is right here. That's point R. Point S is negative 3 and 3. And point T is 1 and 4. 1 and 4. So this is our image. And we're going to reflect this over a line of reflection. So I'm going to connect everything. Okay. So if you notice, for you to get the rule, when you reflect this, and let's reflect just point R here. Point R is 1, 2, 3, 4 units away from the line reflection. Point R prime is going to be 1, 2, 3, 4 units on the other side of the line reflection, and that's R prime. So if you look at R and I prime, what do you notice? Well, I notice that the x coordinate didn't change. They're both going to be still a negative 7, but one was 4 up, right? And the other one is 4 down. So the x stays the same, but the y coordinate, you can negate it. So point R prime, it's still negative 7, but it's negative 7 with negative 4. So all you got to do is negate the second number. S, still going to be negative 3, but the second number, negative 3, changes to positive 3. Sorry, S prime. So S prime is going to be 1, 2, 3, and notice it's right here. Same distance away. Let me erase this because this gets confusing. Take that away. And then T prime, well, T is 1, 2, 3, 4 units, so 1, 2, 3, 4. Here's T prime. Can we connect them? Yep. And then, sorry, T prime is going to be same two numbers, except that the y is going to change. Instead of 1 and 4, it is now 1, negative 4. And that's the rule for reflection over the x-axis. Hopefully so far so good. Okay. Line is x equals 2, so go to x. Where's x? My x-axis. This is the line where x equals 2. A little better. This is the line where x equals 2. And just to recap, Why is that line called x equals 2? Well, let me pick some points on this. Let's look at this point right here. That point is 2 and 1. The next one, 2 and 2. The next one, 2 and 3. The next one, 2 and 4. See something in common? The next one, 2 and 5. Notice that the x coordinate for each of these points is 2. So in all, every single point on this line, right, and there's billions and billions of points on this line, guess what the first coordinate is going to be? 2. That's why that line is called x equals 2, where every point, the first coordinate is equal to 2. That's our line of reflection. So let's plot A equals 1 and 5. 8, 1 and 5 is right here. So that's point A. Same rule. If you're standing, if that's Alex standing right there, where is this image? His image is right here. That's where A prime is. Same distance away from the line of reflection. That's it. Okay, so A prime, it's going to be 3, 5. B prime, well, let's see where B is. First of all, -3 and 2. Here's what B is. B prime would be 1, 2, 3, 4, 5 units on the other side. So 1, 2, 3, 4, 5. Here's B prime, which is 7, 2. C prime. Well, first of all, C is -1 and 3. Here's where C would be. So C prime would be 1, 2, 3. So, sorry, C is 1, 2, 3 to the line of reflection. So C prime would be 1, 2, 3. So C prime will also be, right, 3 units. So it's a very, again, that's your triangle. And again, right here, that's our triangle. Right, so that last line, I gotta just do it better. Okay, there, still a triangle. Now, rule. Let me just get the C prime. C prime is 5, 3. I won't do it for all of them, but you do it if you want. The rule. So when we talked about this, so notice one thing. A and A prime, the Y value didn't change. So let me write A right here next to it. A was 1 and 5. Let me write all of them. B was -3 and 2. And C was -1 and 3. So you want to compare. So X, Y. So notice what changed. So notice that these guys here, the Y value didn't change, right? We didn't go up and down. We went left and right, but we didn't go up and down. So the rule is the Y stays the same because we didn't go up and down. And the X value, to find the X value, we remember what I said, we're going to multiply 2 times the line of reflection, K, and then subtract the X value. So 2K, and what's K in this case? K equals 2. So let's just try for point A. So if you do point A, 1, 5, right? And let's follow the formula. So we're going to go 2 times 2, because the line of reflection is 2, minus X, and well, how much is X right now? Well, the X value is 1, minus a comma Y, which is 5. So A prime, sorry, A, which is 1 and 5, it's going to turn into, well, 2 times 2 is 4, minus 1 is 3, comma 5. Isn't that what we got here before? It is. So you can try that with points B and C. Okay. So when you're reflecting over x equals 2, x equals 3, x equals 4, right? A vertical line where x equals something, this is your formula. And the only difference between this one and when you have y equals something as your line of reflection, let me move something. It's, what the heck? Objects? Okay. Is that, so the bottom one, let me start with the line of reflection. No, y equals -3. Here's my line of reflection, right? So with this one, let me plot one of the numbers so you can see. Let's go -6 and 5. -6 and -5 is here. This is plot point A. You're going to reflect this over the line y equals -3. Well, it's going to be 1, 2, 3 units away, so A prime is going to be 1, 2, 3 units away. So here's A prime. So now notice that A, which was -6, -5, became A prime, and A prime is -6, comma 1. The x values didn't change. Notice that, hey, this is the exact same thing, but the y values changed. So you can do this, right, just by counting. But if you wanted the rule, how do we write the rule? Well, x, y, so the x stay exactly the same. And what are you going to do to find y? Well, you're going to do 2 times k minus 1 minus y. Okay, so let's do that for a, and let's see if it works. I'll do it right under it. So a was -6, -5, right? So to get a prime, the x stays the same, so leave it at -6. And then we're going to go 2 times k, which is -3, minus y, which in this case is -5. So be careful with this. Okay, let's see if that works. So a prime is -6. 2 times -3 is -6, right? Minus -5 is the same thing as +5, and -6 plus 5 is -1. So we get -6, comma, +1. Uh-oh, did I count this wrong? No, it's, no, hang on. That's +5, -6, plus 5 is -1, and we had gotten 1 before. Why did I make, so what's point A? -6 and -5. Our line reflection is y equals -3. Okay, my line reflection is incorrect. So my line reflection, it should be 1 over down. That's my mistake. So let me just fix these things. Okay, so my calculations are correct. Let me just fix this. So -6, -5 is here. That's point A. A prime is 2 units away. So notice that this is 2 units away from the line of reflection. So A prime is here. Right, so point A is still -6, -5, and point A prime is -6, -1. Okay, allow me to do this with B because I made a mess of A, so let me do it with B. Excuse me. So let's do point B. Point B is -0. Did I really write -0? Sorry. 0, -8. 0, -8 is right here. And that's B. So that's 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, and here's B prime. Okay, so B prime is 0, comma 2. Let's see if we can use our formula. So let's start with B, which is 0, comma -8. To find B prime, we keep the first number, right? X doesn't change, but the Y, and to find Y without this, we would have done 2 times -3, which is what k is, minus -8. That's how you should have written it. So B prime, 0, comma, 2 times -3 is -6, and -6 minus -8 is the same thing as -6 plus 8, which equals 2. So B prime is 0, comma 2, which is exactly what we got. Okay? That's probably the hardest part, if anything, that you have to do. So what we did today, a reflection over y equals x. So go back to our slope days, right? So y equals x is the same thing as y equals 1x, and we want to put that 1 over 1. If I asked you to graph this a few weeks or a few months ago, that has a slope of 1, which means up and down you go 1, right? And left and right you also go 1. So starting from the origin, well, remember this has a y-intercept of 0. So 1 up, 1 to the right, 1 up to the right, right? This would have been some of the points on the line. And you would have connected the dots, right? So we're not going to do that, but I'm just showing it to you. So we're going to draw a line that goes through the origin and has a slope of 1. And that's the line. And we're going to reflect over that line. Okay, so the rule we learned today, xy that you notice from observing the points, okay, is that what happens? All you gotta do is switch. So let's do 4, -2. 4, -2 is right here. That's point C. And remember, you're going this way, that direction, right? Perpendicular. Right? You're going that way. So point C is going to be somewhere over here. Okay, so let me erase all that. Let's actually find point C. So point C is 4, -2. It's right here. So we're going to go through one diagonal, two diagonals, three. On the other side, so I don't know why I put C prime, it's point C. On the other side, point C is going to go same thing through one box, right, diagonal, another one, and another. Three of them. And here's C prime. Well, let's see if this rule works, because the rule said, hey, here's C, which was 4, -2, and they're telling me that all I had to do was switch them. Oh, is that true? Well, if you count here, is this point really -2 and 4? Yeah, 2 to the left and 4 up. We are golden. U is 5, -6, 5 and -6, which is right here. That's point U. So according to the rule, to find U prime, all you have to do is switch them. So -6 and 5, -6 going this way and 5 up, and this is point U. U prime. Okay. So again, if you count the diagonals, look, it's one diagonal, two diagonals, three diagonals, four diagonals, five diagonals, and a half. A half, 1, 2, 3, 4, 5. Exactly the same. And then we have point, what is the other point? Point B. 2 and -3 to become B prime. Switch them. That's it. No negations, nothing necessary. So B is 2 and -3, 2 and -3, which is right over here. That's B. B prime is going to be -3 and 2 right here. Okay. So you had, that's it. I don't know what else to say. That's really it. Okay. Probably the easiest of the rules, if there's such a thing. Clear objects. All right. So and the next one is when the slope is negative. That's a slope of -1. Slope of -1. When you graph it, it looks like this, right? Negative slope. Right, and it goes through the origin, because that's our y-intercept. Okay, and what are points? So let me do one, and then we can figure out what the rule is. So point is -7 and 2. -7 and +2 is here. And we'll call that W. It's reflection. It's going to be on the other side. So it's going to be one diagonal, two diagonals, and a half, 1, and 2. So there is. This is where W prime is. So W was -7 and 2, which became W prime, and the coordinates of W prime is -2 and 7. So if you look at these two numbers, right, notice that they switch positions. What else did happen? Well, -7 is now 7, so you definitely have to negate that, right? So if it was negative, now it's positive. What about the 2? It was +2, that's -2, so that also had to be negated. So whatever, so you switch sides, right, you switch places, and whatever signs they were, you gotta switch them to the opposite. So let's do x, -5 and -5, and -5 and -5 over here. That's point x, and let's do it this way, -5 and -5. So point x prime, they will switch places, and we're going to switch signs for both of them. They're both negative, now they're both positive. So 5 and 5 is here. That's x prime. So let me count diagonals here. One diagonal, two diagonals, 3, 4, 5. on the other side. 1, 2, 3, 4, 5. Perfect. Last one is z. Z is 2 and 3. It's going to become z prime, and we're going to switch them, and we're going to negate both of them. So the 3 was positive is now negative. The 2 was positive is now negative. So z, which is 2 and 3, 2 and 3 is right here. And z prime is going to be negative 3, negative 2. Right here. So again, this goes through 1, 2, and a half diagonals, and this goes 1, 2, a half diagonal. So there is our, those are their images, right? The point, the original one, and its image across the line of reflection. Pretty simple. Okay, this one, take point G. So again, on the test, it won't kill you to do this. Come on, clear. Right, so just for you, maybe a little bit in the corner. 8, negative 4. Notice that the x is positive, the y is negative, so that would put him here. So point G is right here. I'm going to reflect this over the y-axis. So this is the y-axis. So point G is going to go from there to here. And so this is where G prime is going to be. Just a little thing for you to look at. So what's the rule? Well, you're going to have the rule. So x, y. So what happens to these 2 points? Well, the x is going to change, right? The y, the point G didn't go up and down, so the y stays, but the x is negated. So point G, which is 8, negative 4, is going to become G prime, which is still, right? It's going to stay in the same position, but guess what? We're going to negate the x. 8 was positive, it's now negative. The y was negative 4, and that stays the same. Ta-da! Reflect L and P over the x-axis. So again, draw this, just for you to know. And we're reflecting this over the x-axis. So this is your line of reflection. Where's L? L is negative 4, negative 8, which is somewhere over here. It doesn't matter. It's just in quadrant 2. And P is in negative 6 and 5. Where's negative 6 and 5? P is over here. Okay, negative 6 and 5. Here's P. So they're both going to, so L prime, this L prime is going to go this way, but P prime is going to go down here. Not a big deal. Right? It depends on which side of the mirror you're in, right? If you're on the downside, your image is going to be on the upside. If you're on the upside, your image is going to be on the downside. So remember the rule, over the x-axis. So if you're reflecting over the x-axis, your x value stays the same because you're not shifting left and right, but your y value is going to be negated. That's how simple that is. So if you look at point L, it's negative 4, negative 8. L prime, so don't touch the x, which is negative 4, but negative 8 becomes now positive 8. So that's the first one. Point P, right here. Point P, which is negative 6 and 5, right? So when you reflect it, the x is going to stay the same. Negative 6 still stays negative 6, but your y value, which is positive 5, now becomes negative 5. And that's the answer. Oh my god. All right, we're almost done. Let's do, I'm going to skip. I'm going to do, well, I'm not going to skip. Okay, so graph. 0.62 is over here, so I'm going to put that this is R. Y equals negative 4, right, is right over here. So this is what you write when y is negative 4. So this is the line, y is negative 4. So point R is going to be reflective over the y equals negative 4. So point R prime is going to be somewhere over here. This is just for you to see what's happening. Now, if you know what's happening, x, y, let me write the rule at the bottom where it says rule. Notice that your x value is not going to change because you're not going left or right. Your x value is not going to change, but your y value is going to change. So you're going to do 2 times k minus your y value. So let's do that. So we had a point R called 6, 2. How is it going to change? Well, first of all, the x it's not going to do anything. So that 6 is still going to be 6. But the y value, we're going to take 2 multiplied by -4 and then subtract the y value, which is 2. 2 times -4 is -8, and -8 minus 2 is -10. So our final answer for point R prime would be this. Okay. Now over here, if I do a little thingy, my line of reflection is x equals 3. So let me just, this is my y-axis, this is my x-axis, and then my line of reflection is here. X equals 3, and I'll write x equals 3, okay, for you to see. We have a point -5 and 2, -5 and 2. Let's call that E. And then the point 2 and -3, somewhere over here. Right? So they're going to go, so E prime is going to be somewhere over here. And B prime is going to be somewhere over here. That's just for you to see what type of movement. Are they going up and down? Are they shifting up and down? No. As far as the y values, that's going to stay the same. But their x value is going to switch. So the rule for this one is xy, right? The x stays the same. Sorry. The x is going to change, apologies. So we're going to go 2k minus x, but the y values stay the same. So that's the formula you want to use. Let's try point E. Point E is -5, 2. So change colors. The y value stays the same, so we know this is already 2. But we got to figure out what the x value is going to be. So it's 2 times k, which in this case is 3, so 2 times 3, minus the x value, which is -5. So 2 times 3 is 6, and 6 minus -5 is the same thing as adding 5. So E prime is 11 and 2. Okay. B prime, sorry. So B, which is 2, -3, to become B prime. So we know the y value stays the same. So this is going to stay as -3. So this doesn't change. But the x value, it's 2 times k, which is we know is 3. 2 times 3 minus 2, because that's the x value, right? So B prime is 2 times 3 is 6, minus 2 is 4, -3. So that's the coordinate for for B prime. Reflect over y equals x. So remember, y equals x. Again, just so that you know, it's this line right here. The line y equals x. And when we reflect, so what's the rule? So if you remember the rule, this becomes so easy. So a reflection over y equals x, what do we have to do? Just switch them. That's it. Nothing else. So R, which is 6, -4, becomes R prime, and it becomes -4, 6. T, and I'll do it over here, which is 8, 1, it's going to become T prime, and it's just 1, 8. That's it. This guy over here, it's a reflection over this line. It's a negative, the slope is negative, so this is the line you're reflecting over. Okay, what's the rule for that reflection? So xy. Again, switch, but make sure you negate everybody. Let's look at point M. Point M is -5, -2. To become M prime, you're going to switch, and they're going to be negated. So whatever they were, they're going to become opposite. So if they're both negative in this case, so they're now both positive. J prime, -1 and 3 to become J prime. Sorry, J, -1, 3 to become J prime. You're going to switch, right? So -1 is going to become +1, and 3, which is positive, is now negative. So make sure you switch and change their signs. That's it. That's really it. Describe the reflection. So here's what I would do here. Well, first of all, they tell you it's a reflection, so that it's first thing I would do is pick one point. Okay, you know it's a reflection, right? So where's the line of reflection? Well, the line of reflection is here, right? So focus on one point. Don't look at everything. So focus on F and F prime. Does that make sense that that's the line of reflection? Yes, it is. They're both 1 unit away from the line of reflection, and you can do the rest as well. But I would focus on 1 or 2 points, and that should be more than enough for you to figure out what kind of reflection it is when we make that line. So this is a reflection over what line? Is it over the x-axis? No, but it's over x, actually this is over y equals, because this is 1, y equals 2. A reflection over y equals 2. This one, well, I think you can see that the line reflection is right here. Right, so this is a reflection over y equals negative x. This one, I don't know. Clear page. Okay, there we go. This one, let's find the line reflection. Well, the line reflection, that's not that hard to see, it's right here. Okay, so this is a reflection over x, x equals, well, -1, -2, -3 over x equals -3. Okay? Notice that everything is equally distant from the line of reflection. This is a rotation. Again, this one, pick 1 point. Not on the axis, pick, I don't know, pick R. We know that's the original one because this one says R prime. So R, which was in quadrant 2, became R prime, which is in quadrant 1. So how much did it travel? 1 over. And what direction did it go? It went this way. Right? So when you travel 1 quadrant over, it's a rotation of 90 degrees. In which direction? Well, in this case, clockwise. Right? Because it went from where R is and where R prime is. It went this direction. This one, again, pick 1 point. Let's focus on T here. T is in quadrant 1. T prime is in quadrant 3. That's 2 quadrants over. So T traveled 2 quadrants over. So it's 2 quadrants over. It's a rotation of 180 degrees. That's how simple it is. What is this one? Again, pick a point. And I would pick, I don't know, I would pick on y and y prime. So y is in quadrant 2. Y prime is in quadrant 4. So notice that from quadrant 2 to 4 is 2 quadrants over, right? 2 quadrants over, and you know that when you travel 2 quadrants over, it means that it's a 180 degree rotation, and we don't care if it's clockwise or counter, because you end up in the same spot. And then we have, and that's it. Oh my god, I thought it'd be longer. And that's it. Literally, that's it. Oh, I forgot. I need a word. There we go. Your word's gonna be Tabasco.